So glad you stopped by. So anyway, as I was saying, Robert, Robbie, Bobby, Bob, let's go with that. Try to make these videos somewhat entertaining, for the students. Really do, while at the same time trying to get information in there they need in order to learn the math and be able to do the assignments.
Oh, that's really cool. I appreciate the kind of complexity of it.
So back when you were in high school, you were a big fan of math and math class, right?
Sure.
Yeah, that's cool, man. I was talking with our principal, Dr. Guthrie, this week. You did know that he graduated with his doctorate, right?
Yeah, he's becoming a better guy.
Yeah, we were talking about, we've got all these lessons out there, all these great lessons, and that, some students they're skipping the videos and just going straight to the assignments and trying to do the assignments without ever learning the lesson. I mean, that wasn't you in school, right? You were one of the ones that paid attention to the lesson, right?
Sure.
Yeah, some of the students, they're really sharp in math, and they don't have a lot of problem doing that. If there's something they don't understand, they look it up on the internet, and they seem to do okay. But there's a lot of these students that, man, they have no idea what's going on. You can tell by what they make no sense with the answers they put on there. They really need to be watching the video.
Are we promoting a movie?
Oh, sorry. Where was I?
Your foot's starting to jump a little bit. You better get to your next question.
Right. So we're just about to wrap up the school year, and
What are we doing?
oh man, it's late. I got to do a lesson. I got students waiting on me. I'm sorry. I got to run.
Bye.
Oh, cue my intro. For the Module 9 test, I've already posted a practice test that I took. I took all the practice tests, so that should be a good review before you take Part 1, if you haven't taken that yet, because I do all of those problems. And the Part 1 multiple choice is modeled much like a lot of the practice test. So you can go through and watch me take that practice test. It should help you on any questions you have, anything you're still trying to understand. That would help you on Part 1. So Part 2, I want to do a quick review here, just kind of go over the 4 problems to kind of let you know what to expect. The first problem is going to have 2. Well, let me just show you this. Let me just show you this. Let's say, for example, and this is not what the test question is. Let's say, for example, that I have 2 triangles that I'm trying to prove are similar to one another. Right? Remember we did triangles, months ago. But when we proved 2 triangles, there's more than one way to do it. But one way to do it is we could have proved that 2 sides and the angle that's in between them are all the same. Or we could prove that all 3 angles are exactly the same, and so those 2 triangles must be similar. Or we could prove that all 3 sides are proportional to one another, right? But some combination of angles and sides we could do if we had the right sides and angles to prove that they are similar. The other thing we could do is we could do it by a dilation and a translation, right? We could translate this point right over here, 0, 2, and this point here. So I could translate this purple triangle 4 to the right and up 2. And then I could dilate it times 2. And since those 2 triangles would be right on top of one another and look exactly the same, that would prove that they're similar because I could translate it over 4 up 2 and then dilate it times 2. So what if, and this does relate to the test, so pay attention, what if I gave you 2 circles and I said, prove they are similar? Well, you might have a little bit of trouble with that angle thing that we did at the triangles, because you don't have that to work with. You might have a little trouble with the side length because it's a circle. So just think about, how would you prove those similar? I'll just let you extrapolate from the examples I gave you on the triangles. So, all right. Let me talk about question number 2. You will have one of these problems where you have like a circle with an inscribed quadrilateral of some shape where it's inscribed where all four corners are on the circle, so it is inscribed quadrilateral, and it will give you, for example, it'll label it. Let's say this is MNOP, and it'll say, how big is angle N, for example. All right. How big is angle N? And here's what it'll tell you. It won't tell you that this is 110 degrees or this is 80 degrees or anything like that. It will tell you that this is Y and this is 2Y and this is Y plus 10 and this is 3Y minus 30. Did that help? This is Y degrees. This is 2Y degrees. And from that, you should be able to come up with an answer on how large is angle N. And how do you know that? Well, if you remember the properties, this angle right here, the yellow angles, and then these two orange angles, if I add those pairs together, the pair of yellow angles or the pair of orange angles, these will equal 180 degrees. And then the two orange ones will also equal 180 degrees. So if I knew that Y plus the 2Y equaled 180 degrees, I should be able to get down to give how big angle N is. I should also be able to tell you what O, P, and M are at that point. How big is M? If I ask that. So if I found out that this was 3Y equals 180, so Y equals 60, because I want to divide both sides by 3. So this must equal 70, because it's Y plus 10. This must equal 120, right? Well, I should be able to do all of them. That should be 60. I should be able to do all of them based on how that works. And this one, I gave a bad equation that doesn't work. This would be 3Y minus 70, because it has to be 110 degrees. Once we know that one's 70, we know this has to be 110. Because they have to add up to 180. Remember, they have to add up to 180. So 110 plus 70 is 180. So as long as you know that they add up to 180 and these add up to 180, you're in good shape. Question number 3. It's going to talk about, what do you know, a Ferris wheel. And it's going to tell you the radius. It's going to say how many cars are on it. It's going to ask you for a central angle. Right? How big is the central angle? And that's going to be between two cars. If I got a car here and a car here, as I go around there, the central angle would be the angle between the two cars on the Ferris wheel. So it'll ask you for the central angle. It'll ask you for the arc length, which is how far is it between these two cars right there. And then it will ask you for the area of a sector. And that would be this entire little yellow area right there between those two cars, that sector. So you got the central angle. What's the angle make right here? Which is also equal to this, right? If this is 10 degrees, then this is a measurement of 10 degrees in degrees. But the arc length, we want to know that in radians, which would be, if this has a radius of 10, you'd have to do 2 times 10 times a pi, right? You got to figure out the circumference of the whole thing, and then how much is just 10 degrees of that whole circumference, right? And then the area sector. This is just like the London Eye project, the Star of Nanchang, or whichever one of those Ferris wheels you chose. That's just like the project that you've already done. So I'm not going to spend any more time on that. The last one you have, I want you to find the center and radius of a circle, and it'll give you an equation like x squared minus 6x plus y squared minus 12y equals 10. we'll say, what is the center and radius of that circle? Which means you got to go back and complete the square. I mean, you got to complete the square. So I got to go x squared minus 6x. And when I do the whole completing the square thing, I find out I got to add a 9. And then I got to do the y squared minus 12y. And when I do the whole completing the square thing, I'm going to add a 36. And then over here, I've got to add that same 9 and that same 36. Right? Remember, I do that by, this is the x's, this is the y's. I take the negative 6, I divide it by 2. That's negative 3. And then when I square the negative 3, I get the 9 that I'm adding. But now this is a perfect square, so this is x minus 3 squared plus, and this is y minus 6 squared, and it equals 55. So from that, you should be able to tell me the radius and the center of the circle. As long as you know how the equation of a circle works. I turn this into an equation of a circle that looks more standard form that we're used to. And this will tell you the center and the radius right there. Remember, this is r squared. So in this case, our radius would be square root of 55, which is not a whole number in this case. Yours may be or may not be a whole number in the problem. The chances are it's probably more of a whole number than what I just made up. So that is the 4 problems you will see on the part 2 of the exam. So I'll remind you that after this will be the last assignment for the semester. So you need to go back after this, look at your grade, and make sure you have all assignments in. Go back to the very beginning of January, module 6, and look through each thing on Buzz. Or you can look in the Home Access Center, see if there's any ends. If there's an end in the Home Access Center, it means it's missing. Right? If you look in Buzz, you see a 0 and something you didn't turn in, there's a 0 there. You need to go back and do that because that's a missing assignment. And then you will be required to take the final if you have a missing assignment. Yes, even if it's a practice test. Practice tests are an assignment. They're not an assignment that affects your grade, but they are an assignment. So any missing assignments will cause you to have to take the final. Now, the nice thing is if you can get everything turned in and you don't have any dues or fees owed to the school, which some of you still do, then you're exempt from the final and you can still take the final. I know how much you love math. We all want to take the final, but you can still take the final. And if you do poorly, I throw it out. If you have all your assignments in and are exempt. If you're not exempt, that bad grade will hit the grade book and won't do nice things to your grade. But you don't want to have to worry about that option. If you get everything turned in, no dues or fees, be exempt, then you can take the final guilt-free, knowing that, hey, this will not lower my grade in any form or fashion because I'm exempt and having to take it to start with. That's where you want to be. So let me know if you have questions. You can email me. I still have some sign-up times available. I'm going to try to put some out for next week also. Next Friday, the 21st of May, is the deadline for all the assignments to be in so you can earn an exemption. Right. So I will assign exemptions after that, after make sure you get everything turned in. So, all right. Do work you could be proud of.